Hello programming engineers, welcome back once more to this drives course, and this video is to show you our Delta drive. This small drive is the one that's going to be joining us in this course, specifically for this section. So we're going to start off with our AC motor, and we're going to show you that from what we've seen in class, we're going to be using 4 different drives to start the same motor. Okay? All right. Now, what do I want us to see here on this side? First off, I'd like us to notice our characteristics. So I'm going to do a very slight close-up. So we're going to analyze. Let's try to get this as close as possible. Okay. It's better if we try it on this side. We'll just adjust this here. There we go. This is already focused. All right, so what do we have here? If we turn our drive on the right, or on the box, whatever box you have, on this side we have our model, which I had already attached on the spreadsheet. So we have our input to our drive. So our input is giving us 2 options, which I'm going to tell you later on, but these are very simple choices. 2 options: regular, normal duty, and heavy duty. Okay? Now, let's leave this as normal duty. Okay? Now it's saying that this is triple loop or triple phase for 240 volts between 50 and 60 hertz at 6 amps. But at the moment, when we assign the electrical installment or installation, we need to be very careful with this. We need to be very careful when adding our thermomagnetic motor. So on the heavy duty part, we have a different type of amperage, which is 5.8 amps. And then it's going to give us the output potency, which is what we are really interested in. From that to how much does it take for the drive? Till 0.75 kilowatts. So this means that this is an HP drive. It's tri-phased from 0 to 230 volts on the normal duty part. And on the heavy duty part, which means for applications with a lot of torque, with continuous use for an extended amount of time, it is 4.8 amps, and because of this, 1 horsepower. Okay? So I'm going to leave this here. And now I'd like us to analyze the inside of the drive. Okay, so here we go. Alright, so why the inside? What does this have? So I'm going to remove the lid. If you can see here on the sides, we have some tabs here. So this is what tells us that we have to press on the side and just lift. It's pretty simple. Now, what do we have here? All right, so let's see here. I'm going to focus. And okay. So I have to get my camera at a closer angle, but anyways, let's talk about this so that this is a little bit more general. Check this out, guys. We have our potency. We have our feed, L1, L2, L3. This is where I could get, or I should get, my tri-phase feed. And this is where we are going to get my feed for my motor. This is feed for the drive, and this is feed for, or to assign voltage to my motor, and that way we can move this. Okay, now what is this? This is simply our inputs and outputs. This is the control part. Okay, this is what we've been looking into basically in our latest topics. Now, what else do we have here? We have our drive as such. So what I had told you about Delta, which is something that I love, is its simplicity. It really respects, they really respect in Asia, the cultural part. The simpler, the better. Even with cars. If you have a Japanese car, you'll know this. Okay, they're very simple. Okay? Now, what do we have here on this part? Let's see here. Let's try to get this closer. And then we're also going to see how. Here we go. Here we go. So that top part is the safety part. We're not looking into this right now, but this, what does this sound like to you? Plus 10 volts, ACM, AV, and ACI. So this sounds like an analog potency meter. This is to connect our potency meter. And on the bottom part, this is where it's a little bit more familiar. These are our digital inputs, nothing that we haven't seen already. And here we finally got RA, RB, and RC. Now, what does this look like? Digital outputs. So it has its connection part with the interface part for its own communication. So that is basically what we need to look into. Now, what is that which we are going to review? We're going to run an electric connection on the digital part. So I'm going to run this and I'm going to show you guys how I did this so that it matches with your diagram. So all you have to do is imagine what process we're going to follow. We're not going to connect any potency meter, but I'd like us to use our potency meter that is by default or included in our drive. Okay? So that's what I need. Now what else? We're going to connect my external digital input, which is what's most used with these drives. Now what else are we going to do here? Obviously, we're going to use a 3-wire start, and we're going to configure everything from scratch. So I should have everything connected, and I'm going to tell you all about this so you can see how the diagram matches with our electric connection. Okay? Especially that I'm going to connect with our motor. I'm going to connect the feed, and I'm also going to connect our digital inputs. Now, what are we going to have as digital inputs? My stop button, my start button, and that's basically it. So with this, guys, after connecting this, I'm going to power on the drive and I'm going to show you the configuration that is set by default. So we're going to try to start this as such with our drive, and we'll see what it does. Now, again, we're going to enter our parameters. We configure them, and then we're also going to see our last try to see what it does with our start button. And also when I select this velocity with the potency meter. Same thing is going to go for the following drive. So obviously we're going to test out if the parameters that we had already entered match. Okay, so having said this, we're going to move on to our next video, guys. Thank you.